Alright, here's another couple examples. So if we've got x plus 2 divided by x squared plus 3x plus 2, we want to check for a whole to see if there's a factor on top and a factor on bottom that end up being the same. Which means we should factor the denominator in this case. So factor in the denominator, what multiplies to 2 adds to 3. That would be a 1 and a 2. So notice that we do have a factor of x plus 2 on bottom and a factor of x plus 2 on top. So if we reduce that, we get 1 over x plus 1. Now this piece that we just reduced, that is going to be the x coordinate for the whole. So where this equals 0 is the x coordinate for the whole. The y-coordinate comes from plugging in this x value into the reduced version of the function. So we'd have 1 over negative 2 plus 1. That gives you 1 over negative 1. So the y-coordinate would be negative 1 for the whole. So again, we reduce the fraction. This part reduces. So x plus 2, how do you make that 0? If x is negative 2, that's the x-coordinate. Plug the x-coordinate into the reduced version. So 1 over x plus 2. Plug the negative 2 in for x. You get an answer of negative 1. That's the y-coordinate for the whole. Okay, the next part we're looking for the vertical asymptote. To find the vertical asymptote, remember that that is where the bottom equals 0. Now we did factor this as x plus 1 and x plus 2. The x plus 2's reduced out, leaving us with 1 over x plus 1. Which means now we are looking for, where does this equal 0? Because we already accounted for the x plus 2. Now we just got to account for the x plus 1. So x plus 1 to equal 0, that means x would equal negative 1. That's our vertical asymptote. So normally we'd have 2 vertical asymptotes, but because this reduced with the top, it became the whole. Alright, the next part you're finding the horizontal or oblique. That's where you divide the highest power from both the top and the bottom, and we're left with 1 over x. Recall that 1 over x, if there's an x left on bottom, that means that y equals 0. If it was a number, then y would be that number, and if we still had an x, we would use long division and it would be oblique. But in this case, there's an x left on bottom, so y equals 0 for your horizontal asymptote. To find the x-intercept, that's where the top equals 0. Now, recall we did factor this, and the x plus 2 reduced out, and we got 1 over x plus 1. So now that we have it reduced, 1 will never equal 0. We can't find an x-intercept because there's none. There's no x on top to find x-intercept. And lastly, the y-intercept. That is where you plug in zeros for all of the x values. As you notice, these would just multiply to 0, and we're left with 2 divided by 2, which is 1. So now as we put all this information on the graph, we have a y-intercept at 1. We have a vertical asymptote at negative 1. And we have a horizontal asymptote at 0. Alright, so you can see that it is in this top right section of the graph. And we also notice that we have a hole at negative 2, negative 1. So we have a hole right here, which means that our graph is in this bottom left corner as well. So there's the graph of our function with the hole at negative 2, negative 1. Right, here's your next example. We got x squared over x minus 2. Look for a whole. That's where a factor on top and a factor on bottom are the same. They reduce out. In this case, there's not one. So we would put none for the whole. Vertical asymptote, that's where the bottom equals 0. So in this case, our x would be 2. That is our vertical asymptote. Horizontal or oblique, we divide these. X squared divided by x, that is x. Which means it's an oblique asymptote, and we're going to have to find the constant that goes with it using long division. So we have x minus 2 going into x squared. When we divided x squared divided by x, we got an answer of x. So I'll put that on top, multiply these through. So we've got x squared minus 2x. Don't forget that with long division you have to subtract. And since there are no x's, I'm just going to put 0x up here. So x squared minus x squared is 0. 0x minus negative 2x, so minus negative, that's plus. So we get 2x. Now we take the next part and we divide. So 2x divided by x, and that gets an answer of 2, so plus 2. Which means our oblique is y equals x plus 2. X-intercept. That's where we set the top equal to 0. So to make x squared equal 0, then the only way is if x equals 0. That's your x-intercept. And recall that anytime you have a 0 for x-intercept, it's also the y-intercept, 0. Now you could plug that in to find the y-intercept. Remember, we plug in zeros for all of the x's, which means on top you have 0, on bottom negative 2, which is 0. Now put in our asymptotes. We have a vertical at 2, and we have an oblique at x plus 2. Now, as you can tell, it's in this bottom left section, so it would be curving close to each one of these asymptotes. And now, on the other part, it's either in the bottom right or the top right. So we need to plug in a number to check. And I'm going to try plugging in, say, a 2. Well, I can't plug in a 2, can I? Because that is where my asymptote is. So I'm going to just go over here and say plug in a 4. Now it doesn't matter, we could have plugged in a 3, a 4, a 5, a 6, etc. I just picked 4 because it was over here somewhere. So I plug in a 4 for both the top and the bottom, all the x's. 4 squared is 16. On the bottom we get 4 minus 2, which is 2. And 16 divided by 2, which is 8. So I plugged in a 4, I got an answer of 8. So you can see that it is up here in this top right corner. So you can draw your lines going through the dot close to the asymptote. There's your graph for this function. Alright, here's another function. We've got 2x squared minus x minus 6. To find the whole, we would need to factor the top. So factoring the top, recall that you can either factor by grouping or factor by diagram method. So if I have 2x squared minus x minus 6, most students liked the grouping method, so I'll quickly go through that. 2x squared minus x minus 6. For grouping method, we multiplied the first and last number together. We got negative 12. As I said, I need the factors of negative 12 to add to negative 1. So that would be a negative 4 and positive 3. So I split this middle factor to be negative 4x and positive 3x. The first factor, or first term, 2x squared, and last term, negative 6, they stay the same. Now I'm going to group together two at a time. So out of the first two, greatest common factor, they're both divisible by 2 and by an x. When I divide by 2x, I'm left with an x for the first term and a negative 2 for the second term. Out of the second set, they're both divisible by 3. So I pull out a positive 3. Once I divide these by 3, I'm left with an x and a minus 2. Now notice that x minus 2's, those are the same for this term and this term. So I can factor it out, x minus 2, and I'm left with 2x plus 3. So x minus 2 and 2x plus 3, those are my factors for the top. So I have x minus 2 and 2x plus 3. Now notice that neither one of those factors cancel with the bottom, so that means there's no holes. Vertical asymptote, recall that's where you set the bottom equal to 0. And for the bottom equals 0, you subtract 1, which means we have vertical asymptote where x equals negative 1. Horizontal / oblique asymptote, recall that that's where they take the highest two powers and we divide them. So 2x squared divided by x, that leaves me with 2x, which means that this one is an oblique asymptote and we're going to have to do long division. So set up long division real quick. We have x plus 1 into 2x squared minus x minus 6. When we divided the 2x squared and the x, we ended up with 2x. So I'm going to multiply those through everything in the front. That would give me 2x squared plus 2x. Now don't forget you do have to subtract these. So the 2x squared minus 2x squared goes away. You have negative x minus 2x, that's negative 3x. Now we only have to do a division left. We have a negative 3x, the thing we just got, divided by the x from up top, and that gives us negative 3. So my oblique asymptote is y equals 2x minus 3. Alright, now the x-intercept, that is where the top is equal to 0. So if we set each one of those factors equal to 0, the first factor equal to 0, x would have to be 2. The second factor equal to 0, we would subtract the 3 and divide by the 2. And then the y-intercept, that's where we plug in 0 for all of the x's. So if I plugged in a 0 for these x's on the top and the bottom, these terms would go away and I'm left with negative 6 over 1, which is negative 6. So now put all of these intercepts on the graph. And I'm also going to put in the asymptotes. So x equals negative 1. And then we have the other asymptote where y equals 2x minus 3. So I'm just putting some dots on here. There's my asymptote going right up through here like this. Now in this case it was really nice. Notice that we have this bottom right and the top left. So we really don't have to find any more points. This graph is nice for us.